Thank you and feel welcome. I just want us to go through a median of grouped data, and I'm going to provide an example. Using that example, we will demonstrate on how to find the median of grouped data. So it goes that the table below shows the distribution of heights to the nearest centimeters of 40 students. So you're given classes with respective frequency as displayed, and therefore for us to be able to determine the median, then we need to introduce another column here, the column of cumulative frequency. And this cumulative frequency, in other words, is defined as the running sum of the frequency. What we do here is we copy the first frequency here, and then we add it across. That is 2 plus 5 to get 7, 7 plus 16 to get 23, 23 plus 9 to get 32, 32 plus 5 to get 37, 37 plus 2 to get 39, and 39 plus 1 to get 40. So the 40 that is coming down here is actually equivalent to the summation of the total frequency. So the number of students at hand at this point is 40. Now, the task here, therefore, we are required to calculate the median height. Now, to calculate this median height, first of all, we have to find what we call the median position. And the median position is actually the total frequency divided by 2. And by this case, it's 40 divided by 2, which is 20. Therefore, realize that the 20th student fall on the class 155 to 159. That is, the 20th student is actually the student that is at the mid, that is the middle student. And therefore, this student falls on the class 155 to 159. This class, we refer to it as the median class. So where the median mark or the median student fall, that class is referred to as the median class. Now we recall that the median of any particular set of data is actually gotten by applying this particular formula. M equals to L plus N over 2 minus C multiplied by I over F. Realize that L, for this case, L is the lower class boundary of the median class. At the same time, N is the total frequency. Also, C is the cumulative frequency above the median class, and I is the class interval, and lastly, F is the frequency of the median class. Once we know those terms, then we can actually substitute those values into the formula to calculate the median. For this case, realize that the lower limit, that is L, from here is 154.5 plus N is 40 over 2 minus C, which is actually the cumulative frequency above the median class. This is the median class here, and the cumulative frequency above the median class indeed is 7. Now we'll say minus 7, and then the class interval will be 159.5 minus 154.5 from here, which we get it as 5, over the frequency of the class, which is 16. Simplifying that, we end up with 154.5 plus 13 over 16 times 5. 13 from here, that is 20, 40 divided by 2, which is 20, minus 7, you get 13. Now, simplifying that one further, we get that M, which is the median, is 154.5 plus 4.0625. That means if you multiply 13 over 16 times 5, we get 4.0625. Now, summing up, we have our median coming to 158.5625 centimeters. And therefore, this one become our median height for that particular data. So subscribe, my good students, subscribe for more interesting lesson, and the forthcoming lesson will be on quartile. And I believe this particular area has enabled you to understand more on median, especially for grouped data. Thank you.